Hello everyone, my name is Edhem Custovic. I'm an academic member here at Trobe University, Melbourne, Australia, and I'm also the director of the Trobe University Innovation and Entrepreneurship Foundry. I first of all want to thank the International Burch University, as well as the Burch Gene Magazine team, for inviting me to say a few things at the launch of your spectacular publication. I do send my sincere apologies for not being able to attend this event physically or join you live. There are other duties which have called upon me, and again, I do apologise for not being there with you, but believe me, I'm there with you in spirit to support you throughout this great journey. As the title of my short little presentation says, BurchGene, more than a magazine. I'm going to briefly explain to you why it is more than just a publication from my perspective and why it's important to disseminate scientific information. But before I do so, I'd like to say a few things about myself before we get into the meat of this presentation. I'm a 33-year-old academic and industry project coordinator based in Melbourne, Australia. But I'm more than that. I consider myself to be truly a global citizen. Not a global citizen because I've travelled around the world to enjoy holidays, but because I work with people in a majority of the countries on our planet. This global citizenship has allowed me to create new businesses, new opportunities, research capability, but also absorb cultural differences and take the best out of them to advance my research and my businesses. I'm a president of the IEEE Victorian section. The IEEE is the world's largest professional body. It has existed for over 125 years, and it also exists in your home country, Bosnia-Herzegovina. So besides my role at the Victorian section level, I'm also a member of the IEEE boards that reside in New York and New Jersey. As part of these boards, I have significant oversight of the overall organisation. I'm a member of the Publications, Products and Services Board, which overlooks all of IEEE's publication services, as well as our recently launched products. And that has some significance over our presentation today here of your publication. I understand what it takes to get a publication, not only online, but the actual curating of content that occurs behind the scenes and the hard work that you guys put in. Besides my publications role, I'm also a member of the IEEE Entrepreneurship Innovation Committees, as well as the industry boards that engage with all sorts of organisations globally. Furthermore, I'm also a mentor to so many students around the world. I'm a mentor to students in Africa, Asia, Australia, Bosnia-Herzegovina, the United States, and so on. I do put a significant amount of my time to mentor young people to successful career paths, providing them with ample opportunities to advance not only their career, but also the careers of those around them. But in my entire very, very busy schedule, I take time. I take time to be involved in publications, dissemination of information. And I'm the editor of numerous publications, online and offline, hard print copy material, blogs, forums, social media, and so on. I take time in my busy schedule to write and communicate engineering, science, and innovation. So that leads me to the next slide, which is a very significant and very important element of what we're doing here today. The significance of publication. So I don't want to go into the details of why it's important to publish, but I want to go into the details of why it's important to be involved in the publication process as a student or a young professional in your industry. First of all, young people develop significant investigative abilities by conducting research. But young people also develop investigative abilities by questioning other people's research, by conducting interviews of professionals around you, by reading information online. You are questioning the information that you are disseminating to others. Your ability to write is very important. Your ability to disseminate that information in a way that other people can understand will significantly advance our understanding of science and engineering in general. Through this process, you also develop interpersonal skills that will advance your career as a scientist, engineer, or any other kind of professional around the world. You must connect with researchers, and you must be able to draw in on their expertise to advance your own knowledge, but as well as those of others. And throughout all of these tasks that I've outlined, not only are you bettering yourself, but you're creating communities. You are truly building a community of scientists and engineers, young people, as well as those that are more senior to you, surrounded by information, but hovering around important topics that are helping advance our planet and solving major problems around the world. And lastly, I want to leave you with a very important statement. It is not good enough to just conduct scientific work. It is our duty as scientists, engineers, and people who solve problems to communicate it to the rest of the world. By communicating this information, we're also helping accelerate the process of discovery. We're helping people understand the significance of our work, and we're also advancing science as a whole. Now that we truly understand the importance of disseminating information, let us have a look at some of the interdisciplinary elements of science and how they are driving advancement in our society. Science is truly interdisciplinary, and in order to make the breakthroughs that are needed in science to advance humanity, we must be willing to open up to new ideas and work with people that we have not worked with in the past. There are hundreds of challenges that we face today, including feeding the planet, providing healthcare, reducing carbon emissions, providing adequate communications all over the world, dealing with globalization and urbanization, security threats, not only physical but also cyber, as well as exploration to other planets. But I would love to spend some time discussing all of the major issues that our planet is facing. Today's focus will be on feeding the planet. When we think about the threats to the environment, we tend to picture cars and smokestacks, not dinner. But the truth is, our need for food poses one of the biggest dangers to the planet. Agriculture is amongst the greatest contributors to global warming, emitting more greenhouse gases than all of our cars, trucks, trains, airplanes combined. Largely from methane released by cattle and rice farms, nitrous oxide from fertilized fields, and carbon dioxide from cutting of rainforests to grow crops or raise livestock. Farming is the thirstiest user of our precious water supply and a major polluter, as runoff from fertilizers and manure disrupt fragile lakes, rivers, and coastal ecosystems across the globe. Agriculture also accelerates the loss of biodiversity, as we've cleared areas of grassland and forested farms were not crucial to habitat, making agriculture a major driver of wildlife extinction. The environmental challenges posed by agriculture are huge, and they'll only become more pressing as we try to meet the growing need for food worldwide. It is very likely that we will have 2 billion more mouths to feed by the middle of this century. More than 9 billion people. Think about that for a second. But sheer population growth isn't the only reason we'll need more food. The spread of prosperity across the world, especially in countries like China and India, is driving an increased demand for meat, eggs, and dairy, boosting pressure to grow more corn and soybeans to feed more cattle, more pigs, and chickens. If these trends continue, the double whammy of population growth and richer diets will require us to roughly double the amount of crops we grow by 2050. Unfortunately, the debate over how we do this and the global food challenge has become polarized. So let us examine ways that we could improve all of this. How can the world double the availability of food while simultaneously cutting the environmental harm caused by agriculture? Catch-22 sounds like a very difficult problem, and in fact it is. But there's a 5-step approach that can be looked at in order to do this. First of all, step 1, freezing agricultural footprints. For most of history, we've been cutting down forests all over the world in order to create more arable land and create more food. We've already cleared an area of roughly the size of South America to grow crops. Right? Think about that for 1 second. The size of South America has been cleared of forests in order to grow food. So to raise livestock, we've taken even more land, an area roughly of the size of Africa. So 2 continents worth are gone. The agricultural footprint has caused the loss of a whole ecosystem around the globe. Step 2, we need to grow more on farms we've got. That means efficiency. That means the world can turn its attention to increasing yields on less productive farmlands, especially in places like Africa, Latin America, and parts of Eastern Europe, including Bosnia-Herzegovina, where a lot of land is currently unused. There are what we call yield gaps between current production levels and those possible with improved farming practices. The need to use high-tech precision farming systems is crucial, as well as approaches borrowed from organic farming and blending them together to get a more productive outcome. Let's look at step 3, using resources more efficiently. We already have ways to achieve higher yields, and there are new conducted research elements being undertaken to improve this even further, while also dramatically reducing the environmental impacts of the conventional farming. The Green Revolution relied on intensive and unsustainable use of water and fossil fuel-based chemicals, but commercial farming has started to make huge strides, finding innovative ways to get better target application of fertilizers and pesticides by using computerized tractors equipped with advanced sensors and GPS. Many growers apply customized blends of fertilizer tailored to their exact soil condition, much like personalized medicine is helping tackle cancer today. This helps minimize the runoff of chemicals into nearby waterways. Step 4, we need to shift diets. It would be far easier to feed 9 billion people by 2050 if more of the crops we grew actually ended up in our stomachs. Today, approximately 50% of the world's crop calories feed people directly, and the rest are fed to livestock, approximately 36%, or turned into biofuels and industrial products, about 9%. Through many of this, we consume meat, dairy and eggs from animals raised on feedlots. Only a fraction of the calories in feed given to livestock actually make it their way into the meat or milk that we consume. For every 100 calories of grain we feed animals, we get only about 40% new calories of milk, 22 calories of eggs, 12 chicken, 10 of pork, or 3 of beef. This is a huge insufficiency in converting what they consume into what we consume. Finding more efficient ways to grow meat and shifting to less meat-intensive diets is actually a better approach. Even just switching from grain-fed beef to meats like chicken, pork, or pasture-raised beef could free up sustainable amounts of food across the world. And lastly, reduction of waste. It's estimated that 25% of the world's food calories and up to 50% of the total food weight are lost or wasted before they can even be consumed. Think about when you eat your next dinner, how much of that food is ending up in the rubbish bin and how much in your stomach. In rich countries, most of that waste occurs in homes, restaurants, or even supermarkets. In poor countries, food is often lost between the farmer and the market due to unreliable storage, transportation. Consumers in the developed world could reduce waste by taking such simple steps as serving smaller portions, eating leftovers, and encouraging cafeterias and restaurants and supermarkets to develop waste-reducing measures. Of all of the options for boosting food availability, tackling waste would be one of the most effective. And with some of these significant challenges upon us, it is a very exciting time to be a scientist, engineer, or someone who just generally wants to innovate and create some absolutely amazing solutions to the things that are coming in the 21st century. But I want to briefly highlight some of the great project work that I'm involved in currently that might be inspirational to you and future generations to come. The first project that I'm going to show you is our understanding of plants, our fundamental understanding of how plants grow, how they absorb nutrients, and how they grow under different conditions. So let me show you this brief little video of our work.
Phosphate. Every single living thing on this planet relies on its existence. Every plant, every creature, every human. But how we use it is just not sustainable. Yes, the more phosphate we use, the greater our crop yields. But the more we use, the more environmental damage we cause through runoff that pollutes our waterways, through the mining process itself. That's only part of the problem. You see, the food chain starts with phosphate. All our food production, all of it, down to the last grain of rice needs phosphate. And it's running out. As less is available, it becomes more expensive. In time, subsistence farmers will struggle to afford enough phosphate to grow enough food to feed themselves. The farming industry worldwide will begin to struggle to grow enough food to feed us all. The food that makes it to market will become more expensive as there becomes less of it, this thing we call food. An over-reliance on phosphate. It's a problem facing the entire planet, affecting the billions of living things on it, including us. But we're working on a solution. We're cultivating plants to be less phosphate reliant, to more efficiently take up the phosphate they do need. And in the process, we're helping to create a more sustainable future for the 7+ billion of us that call Earth home. Phosphate. Every single living thing on Earth needs it, and it's running out.
So we have developed what's called a multispectral, three-dimensional, high-throughput phenotyping system. The field of plant phenomics has emerged from traditional plant physiology with high-resolution, non-invasive imaging technologies. Phenomic experiments record time series data on plant functional traits, as well as top-down and three-dimensional models of plant growth and development, which help us understand their physiology better. This fills an important technology gap that exists between plant genomics and plant phenomics, allowing the full potential and investment in plant genomics to actually be realized. There are lots of large multi-million-dollar plant phenomic facilities around the world. There are several in Australia. The urgency to develop smaller, high-throughput systems for phenotyping plants will ensure that this technology is accessible not only to people who have vast amounts of money for research, but also to the small guys. It's also about redesigning experiments for large facilities. Currently, the cost of carrying out these large experiments in an Australian facility is huge, and it could have wait times of greater than 1 year. This means that small scientists and scientists who want to experiment quickly do not have that accessible to them. This is simply due to the single large facility only being available in a single place, requiring researchers to travel and stay on site for weeks, sometimes months, to carry out their experiments. Such experiments are extremely expensive and also need to be pre-designed to define the parameters that will be assessed. Our system is designed to fill this particular gap. We are proposing to develop a comprehensive multidimensional phenotyping system that will allow specific hypotheses related to genomic or environmental effects to be tested at a much smaller scale. The system will become a highly valuable asset to the world of science. Through accurate control of multiple variables, it will enable testing for different effects on complex traits such as photosynthetic rates and water use efficiency. The system consists of a 1 by 3 meter rack, as you can see from the images here, has an adjustable height tray and accommodates different sized plants ranging from Arabidopsis to wheat. The roof of the system is illuminated using a vast array of LEDs covering wavelengths from 450 nanometers all the way through to 850 nanometers at infrared. The electronic control system also allows us to interface with different types of settings, allowing researchers to mimic and accurately reproduce even the most complex research campaigns based on diurnal and seasonal effects. We propose that each tray in the system will also contain temperature, humidity, and weight sensors. With approximately 20 trays in the system, we can conduct some large-scale experiments very rapidly. Now, I briefly want to mention my foundation, the Bosnia-Herzegovina Futures Foundation, which is, I believe, the cornerstone of the future development and growth of knowledge in Bosnia-Herzegovina, as well as the great work that's being conducted by other organizations. We are empowering the youth of Bosnia-Herzegovina through education, technology access. Furthermore, my foundation actually provides scholarship. It also provides travel grants, allowing students to get a global look on the world. Technology grants to enable them to do things that they can't necessarily do at the moment at their current premises. Mentoring, from leadership expertise to technological expertise, we match students up with experts around the world. We provide internships as well as international and local, and we work on student soft skills as well as their leadership capability to become the true leaders of Bosnia-Herzegovina's science and engineering world. The Bosnia-Herzegovina Futures Foundation is a proud supporter of the Burch Gene Magazine. We see this as an opportunity to promote the great work of the students who run this magazine, but also to disseminate great knowledge amongst their peers and the world. I want to again take the opportunity to thank you all for providing this opportunity to say a few words to you. I wish you all the very best with the Burch Gene Magazine publication. I know it will be a very successful publication, not only this issue, but future issues to come. I want to applaud the significant work, effort and dedication you have put in to provide this information to others to read. I know I will take pleasure in reading all of your publications, and I will continue to support you with everything that I can. Thank you very much, and I wish you all the best for the rest of the day.